All outlets located on the walls above a residential kitchen countertop are required to have ground fault circuit interrupter protection, regardless of the distance from the sink. The National Electrical Code, specifically Section 210.86 in the 2017 edition, addresses this requirement. This section states that in dwelling units, all 125-volt single-phase 15 and 20 amp receptacles installed in the kitchen located within 6 feet or 1.83 meters of the inside wall or countertop surface shall have ground fault circuit interrupter protection. Regarding hydrotherapy tubs, the National Electrical Code 2017 does not mandate ground fault circuit interrupter protection for hydrotherapy tubs installed before January 1, 2018. However, it strongly recommends installing ground fault circuit interrupters for added safety. The National Electrical Code 2023 requires ground fault circuit interrupter protection for all hydrotherapy tubs, regardless of their installation date. Since a hydrotub was installed before January 1, 2018, it is not required to have ground fault circuit interrupter protection under the National Electrical Code 2017. However, it is highly recommended to have a qualified electrician inspect the hydrotub and install a ground fault circuit interrupter for safety. There are several benefits to ground fault circuit interrupter protection. Firstly, it protects against electrical shock by quickly cutting off power when a ground fault occurs. Secondly, it helps prevent fires caused by electrical malfunctions or water damage. Thirdly, it provides peace of mind and increased electrical safety in areas exposed to moisture, such as kitchens and bathrooms. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there is a difference of even a few milliamps between the incoming and outgoing current, the GFCI trips, quickly cutting off the power to the circuit. This difference in current indicates that some of the current is leaking to ground, which could happen if someone were to touch a live wire or if there was a fault in an appliance. The speed at which a GFCI trips is crucial. It typically trips in a fraction of a second, fast enough to prevent serious injury or death. This rapid response is what makes GFCIs so effective at preventing electrical shocks. Ground fault circuit interrupters are commonly found in areas where water is present, such as bathrooms, kitchens, and outdoor locations. This is because water is a good conductor of electricity, and the risk of electrical shock is higher in wet environments. In kitchens, ground fault circuit interrupter protection is required for all receptacles serving countertop surfaces. This includes receptacles located above the countertop, as well as those located on the sides of islands or peninsulas. The reason for this requirement is that kitchen countertops are often wet, and appliances used on countertops, such as toasters and blenders, can easily come into contact with water. In bathrooms, ground fault circuit interrupter protection is required for all receptacles. This includes receptacles near sinks, showers, and bathtubs. The presence of water in bathrooms makes the risk of electrical shock particularly high. Outdoor receptacles are also required to have ground fault circuit interrupter protection. This includes receptacles used for powering outdoor tools, such as lawnmowers and hedge trimmers, as well as receptacles used for outdoor lighting. Rain, snow, and other forms of moisture can increase the risk of electrical shock outdoors. There are two main types of ground fault circuit interrupters. The first type is a ground fault circuit interrupter receptacle, which is a receptacle that has a built-in ground fault circuit interrupter. This type of ground fault circuit interrupter is typically used to protect a single receptacle. The second type of ground fault circuit interrupter is a ground fault circuit interrupter circuit breaker, which is a circuit breaker that has a built-in ground fault circuit interrupter. This type of ground fault circuit interrupter is typically used to protect an entire circuit. When installing a ground fault circuit interrupter, it is important to follow the manufacturer's instructions carefully. It is also important to test the ground fault circuit interrupter regularly to ensure that it is working properly. To test a ground fault circuit interrupter receptacle, press the test button on the receptacle. The receptacle should trip, cutting off the power to the circuit. To reset the receptacle, press the reset button. To test a ground fault circuit interrupter circuit breaker, press the test button on the circuit breaker. The circuit breaker should trip, cutting off the power to the circuit. To reset the circuit breaker, move the breaker handle to the off position and then back to the on position. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. A faulty ground fault circuit interrupter may not provide adequate protection against electrical shock. It is also important to avoid overloading ground fault circuit interrupter circuits. Overloading a circuit can cause the ground fault circuit interrupter to trip frequently, which can be annoying and inconvenient. To avoid overloading a circuit, do not plug too many appliances into the same circuit at the same time. It is also important to use extension cords that are rated for the amount of power that the appliances will draw. Ground fault circuit interrupters are an important safety device that can help to prevent electrical shocks and fires. By understanding how ground fault circuit interrupters work and following the proper installation and testing procedures, you can help to ensure that your home is safe from electrical hazards. The National Electrical Code, often abbreviated as National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association or National Fire Protection Association and is updated every 3 years. The National Electrical Code covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is used by electricians, electrical inspectors, and other professionals involved in the electrical industry. The purpose of the National Electrical Code is to protect people and property from electrical hazards. It does this by providing minimum safety requirements for electrical installations. The National Electrical Code is not a law, but it is often adopted by state and local governments as part of their building codes. This means that electrical installations must comply with the National Electrical Code in order to be considered safe and legal. The National Electrical Code is organized into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring methods or overcurrent protection. Each article covers a specific aspect of that topic, such as the types of wiring methods that are permitted or the requirements for overcurrent protection devices. Each section provides specific requirements for a particular situation. The National Electrical Code is a complex document, but it is essential for anyone involved in the electrical industry to understand its requirements. By following the National Electrical Code, you can help to ensure that electrical installations are safe and compliant. The National Electrical Code is constantly evolving to keep pace with new technologies and changing safety concerns. The National Fire Protection Association regularly updates the National Electrical Code to reflect these changes. The latest edition of the National Electrical Code is the 2023 edition, which was published in August 2022. Some of the key changes in the 2023 National Electrical Code include new requirements for ground fault circuit interrupter protection, arc fault circuit interrupter protection, and surge protection. There are also new requirements for the installation of electric vehicle charging equipment and energy storage systems. It is important for electricians and other electrical professionals to stay up to date on the latest changes to the National Electrical Code. By doing so, they can ensure that their work is safe and compliant with the latest standards. Arc fault circuit interrupters, or arc fault circuit interrupters, are another type of safety device that is designed to protect against electrical fires. Arc fault circuit interrupters work by detecting arc faults, which are dangerous electrical conditions that can cause fires. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two conductors. Arc faults can generate a lot of heat, which can ignite nearby combustible materials and start a fire. Arc fault circuit interrupters are designed to trip when they detect an arc fault, quickly cutting off the power to the circuit and preventing a fire. Arc fault circuit interrupters are typically installed in bedrooms, living rooms, and other areas where people are likely to be sleeping or spending a lot of time. This is because arc faults are more likely to occur in these areas due to the presence of flammable materials such as bedding, furniture, and curtains. Arc fault circuit interrupters are different from ground fault circuit interrupters. Ground fault circuit interrupters protect people from electrical shock, while arc fault circuit interrupters protect against electrical fires. Ground fault circuit interrupters detect ground faults, which are leaks of current to ground. Arc fault circuit interrupters detect arc faults, which are unintentional electrical discharges. Both ground fault circuit interrupters and arc fault circuit interrupters are important safety devices that can help to protect against electrical hazards. Surge protection is another important aspect of electrical safety. Surge protection devices are designed to protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage or destroy electronic devices. Voltage surges can be caused by lightning strikes, power outages, or other electrical events. Surge protection devices work by diverting excess voltage away from electrical equipment, protecting it from damage. Surge protection devices are typically installed at the service entrance of a building, as well as at individual outlets. This provides multiple layers of protection against voltage surges. There are two main types of surge protection devices. The first type is a whole house surge protector, which is installed at the service entrance of a building. This type of surge protector protects all of the electrical equipment in the building from voltage surges. The second type is a point-of-view surge protector, which is installed at an individual outlet. This type of surge protector protects the equipment plugged into that outlet from voltage surges. When choosing a surge protection device, it is important to consider the amount of protection that it provides. The amount of protection is measured in joules. A higher joule rating indicates a greater level of protection. It is also important to choose a surge protection device that is appropriate for the type of equipment that it will be protecting. Some surge protection devices are designed for sensitive electronic equipment, such as computers and televisions, while others are designed for more robust equipment, such as appliances and power tools. Electrical safety is an important topic that should be taken seriously. By following the National Electrical Code and installing the appropriate safety devices, you can help to protect yourself, your family, and your property from electrical hazards. When working with electricity, it is important to always take precautions. Never work on electrical equipment while it is energized. Always turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools when working with electricity. Wear safety glasses to protect your eyes from electrical sparks. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, so it is important to take the necessary precautions to protect yourself. In addition to ground fault circuit interrupters, arc fault circuit interrupters, and surge protection devices, there are other safety devices that can help to protect against electrical hazards. These include smoke detectors, carbon monoxide detectors, and tamper-resistant receptacles. Smoke detectors are designed to detect smoke and sound an alarm warning occupants of a fire. Smoke detectors should be installed in every bedroom, as well as in hallways and on each level of a home. Carbon monoxide detectors are designed to detect carbon monoxide, a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas. Tamper-resistant receptacles are designed to prevent children from inserting objects into the receptacle slots. Tamper-resistant receptacles have spring-loaded shutters that close off the slots when an object is inserted. These receptacles are required in new construction and renovations. By installing these safety devices, you can help to protect your home and family from electrical hazards. Electrical safety is an ongoing process. It is important to regularly inspect your electrical system and make any necessary repairs. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, contact a qualified electrician immediately. By taking these steps, you can help to ensure that your home is safe from electrical hazards. Remember to always follow the National Electrical Code when working with electricity. The National Electrical Code provides minimum safety requirements for electrical installations. By following the National Electrical Code, you can help to ensure that your work is safe and compliant. If you have any questions about electrical safety, consult a qualified electrician. A qualified electrician can provide you with expert advice and assistance. Ground fault circuit interrupters are a critical component of electrical safety in residential kitchens and bathrooms. They provide protection against electrical shock by quickly cutting off power when a ground fault is detected. Arc fault circuit interrupters offer additional protection against electrical fires by detecting and interrupting arc faults. Surge protection devices safeguard electronic equipment from voltage surges. By understanding and implementing these safety measures, homeowners can significantly reduce the risk of electrical hazards.